Formation of ionic bond. That is how that transportation of valence electron occur. Let's see the most common example of sodium chloride. Sodium has an atomic number of 11 with a configuration of 1s2, 2s2, 2p6, 3s1. The nearest noble gas is neon, 1s2, 2s2, 2p6. It's obvious that this 3s1 electron is extra for sodium, which needs to be lost in order to get the configuration of nearest noble gas or the configuration of neon. Hence, the ionization enthalpy of sodium is very low, though this last valence electron is under the influence or quite control of the nucleus, but due to the tendency to achieve the nearest noble gas configuration, this electron is loosely held and is a little amount of energy is needed to overcome the nuclear pull so that this electron could be lost. Similarly, chlorine, which is most electronegative, seeks one electron, has a configuration of 1s2, 2s2, 2p6, 3s2, 3p5. Just one electron shortage from the configuration of argon. This is 3p6. So, how the reaction would take place? The sodium will lose one electron and that electron will be gained by chlorine. Thereby, this will not be there. Sodium ion will have a configuration of 1s2, 2s2, 2p6, the 8 electron in outermost shell, and chloride will have a configuration of 1s2, 2s2, 2p6, 3s2 and 3p6 by the migration of this electron, a complete transfer of this electron. Sodium will achieve the configuration of neon, chlorine will achieve the configuration of argon, but then sodium will no more remain as sodium and chlorine also will no more remain as chlorine. Rather, sodium will change to sodium ion Na plus and chlorine would change to chloride ion Cl minus. So, thereby the electron transference is like this. This is the electron transferred by the sodium. Finally, it has got 288 configuration, 28 or configuration of neon and argon. And since this is a minus and this is a plus, this electrostatic attraction is the ionic bond. We will not write NaCl like this. This is wrong. This bond is only a single line, or which is also known as bond line formula. This is only valid to explain the covalent bond, never the ionic bond. Here in this context, I would like to tell you the electrovalency. Number of electrons lost or number of electrons gained is called electrovalency. Therefore, for sodium, the electrovalency is 1, in fact plus 1, and for chlorine, the electrovalency is minus 1. The magnitude of valency is 1 in both. Plus and minus stands for loss and gain of electron. Let's see the formation of magnesium oxide. Magnesium has a configuration of 1s2, 2s2, 2p6, 3s2. Oxygen has a configuration of 1s2, 2s2, 2p4. Now for this magnesium, these electrons are being extra with respect to neon, and oxygen seeks 2 more electrons to have the configuration of neon. So these 2 electrons will be migrated to oxygen. Magnesium releases 2 electrons, goes to oxygen, and hence it forms Mg2 plus ion. Oxygen forms oxide ion, O2 minus ion. Both are having the configuration of neon. This plus 2 and minus 2 charges are responsible for Coulombic attraction. Formation of MgCl2. Magnesium as a configuration of 1s2, 2s2, 2p6, 3s2, while chlorine has a configuration of 3s2, 3p5. Chlorine can take up only 1 electron, but magnesium is able to do 2 electrons, able to lose 2 electrons. So for every magnesium, we require 2 Cl to accept 2 electrons, and hence it forms Mg2 plus by the loss of 2 electrons, and Cl minus 2Cl minus for the gain of electrons. So finally it forms magnesium ion and two chloride ions. This is how magnesium chloride is being formed. Next, if we want to show the formation of aluminium fluoride molecule, Al is 1s2, 2s2, 2p6, 3s, 2, 3p1. That is as a whole 3 electron in the outermost shell, and fluorine is 1s2, 2s2, 2p5. That means fluorine needs only 1 electron, but aluminium is able to lose how many electrons? 3 electrons in order to achieve the configuration of neon. Therefore, for every aluminium, these are the 3 electrons could be taken by 3 fluorine. This fluorine has 7 electrons, this fluorine also has 7 electrons, this fluorine has 7 electrons. So this electron goes to this fluorine, this electron goes to this fluorine, this electron goes to this fluorine. Aluminium gets a plus 3 charge, and 3F minus would get 8 electrons as this. How this aluminium fluoride is an ionic compound, this is being explained over here.